Hi, this is Roman, and I'm going to review a few ideas for intros, launches, investigation, and assessment for Unit 7, Lesson 1 on lines, angles, and curves. So, the first launch would be a matching activity where you would ask students to make sense of the structure of an image and match it up with the name of the image, and then following that, the definition, right? And as students create the matches, you can then ask them to compare it to the answer key and check for precision, which would be a great idea for discourse within a classroom. Following that, another idea for an intro would be a noticing and wondering activity that follows an interactive activity. So here I'm using the sketch tool, and if you're utilizing Desmos, you'd be able to see this in real time as students do it. So you'd ask students to create a diameter in blue or radius in red and a segment that's neither in orange. I'll model how I would create a diameter in blue here using the segment tool, right? And then you would ask students what they notice and wonder about this image. An idea that I would do here with students would be to possibly add a vocabulary word bank, and when the discourse begins, hold students accountable for using the proper vocabulary in their explanations. So that activity really lends itself to this activity. And if I were doing the pacing in Desmos, I would open up both of these slides so students can flip back and forth, checking the previous activity to answer this activity. So students here would just place a check mark on statements that must be true or possibly true or can't be true. So here to model, I'm using the sketch feature again. If a diameter is a chord, they would just check it off like so. And you could see that on your teacher screen for each student. So from here, an idea for an investigation, and this is from Illustrative Mathematics. I created this figure, and you can create it also using Desmos geometry. So if you type in Desmos/geometry, you get brought to their construction tool, which is very similar to GeoGebra. And you can create figures here that you could end up using in your activities. So from here, I created it so students can manipulate A and D, and as they manipulate A and D, you'll notice that the angles or the central angles are staying the same and the chord lengths are staying the same. You could also change the length of the circle here, making it bigger. Change the circumference of the circle, making it bigger or smaller. So from this, as I build on this activity, again, on the next slide, I would have students think about the question of what's the relationships with the chords and arcs by giving them the definition of a central angle being congruent to the measure of the arc that it intercepts. And again, this is a great idea for investigation. So from here, I'm going to share a few different assessment ideas that are gathered from Illustrative Mathematics and New Visions. So this one is from Illustrative Mathematics. I modified it to make it scaffolded, so I included the statement reason table here, and I filled in the proof of proving that the chords C, B, and D, E would end up being congruent. So students would just fill in the statements or reasons that are missing for this assessment piece. This question is taken from New Visions. It's a great foundational skill here, checking if students are aware of the definition of a central angle. And it could be a great discourse builder here and letting students flesh out each other's misconceptions by questioning, correcting, or clarifying one another. Based on the responses that you gather, you could facilitate that conversation very nicely. So I really enjoyed these assessment pieces that New Visions had. They really brought in ideas that were learned earlier in the year. So here we have the idea of radii being congruent, creating isosceles triangles. And for these questions, utilizing the sketch feature could really let students show their work to you as they're doing it, right? And then again, they're connecting here the idea of a central angle. So one thing that I like about Desmos is the idea of the scientific calculator. So they could do their calculations right in Desmos. They don't have to go to a different application. They don't have to use a cell phone, and it'll calculate it right for them. And there are a lot more complex things they could do with this scientific calculator should they choose. So this is one assessment piece that brings together the idea of isosceles triangles. And again, they would just mark up their answer here. CB, arc CB is equal to 100 degrees, right? And again, they're connecting the idea that a central angle is equal to the arc that it intercepts. So from here, I truly enjoyed this question. From here, again, students are utilizing the fact that they have isosceles triangles created by congruent radii. And here we have students are going to be asked to spiral the idea of a linear pair to find angle RPS. So they would use the idea of a linear pair to find angle RPS and then connect that central angle would be equal to the arc that it intercepts, or arc RS. And again, students get to use this graphic calculator right here to solve this question. The last question models what you could do using Desmos. And again, this question is also taken from New Visions, and it spirals the idea of perpendicular lines and also a segment bisecting an angle. But what I want to highlight is on one screen, you could have students sketch on a diagram to identify congruent angles and mark up ideas that they solve for. So here I can mark up both of these 45 because in the question I am told PL is perpendicular to JR. And then also you could ask an open-ended question to students explaining why arc PQ is congruent to arc QR. And you can have students explain themselves with an open-ended question, and then you can ask them a computational question using a table function here. So again, using a table, they don't even have to click the calculator here. If they want to calculate the solution to a certain question, as soon as they press enter, it'll give them that solution. And one thing I do want to point out, if you press equals for some reason, be more specific with arc JQ would end up being 90 plus 45. It's not going to work. So no equal sign. And that's something you might want to say to your students. They put an equal sign, it won't end up giving them the solution. So these are some assessment ideas, some introduction ideas, and some investigation ideas for this lesson. So you are going to get the link, and you can modify this lesson to any way you like it. You're going to click these three dots, press copy and edit, and then you can make it your own and rename it